EP100. And any computer with Python 3 will do, and I'm just going to use Google Colab. So I want a new notebook. I'll close this old one. And here's my new notebook. All right. So I can create a file called greet.py, but I'm just going to put it not in a file. I'm going to just run it right here in the Colab environment, in which case it doesn't need to be in a file. I can copy it, and I can paste it here. Right-click, I think Command V. There we are. So there it is. This is going to print, and here you just see how to manipulate strings. So a string is hello world, called greet, and I print it, and there it is, hello world. And here's how you get parts of a string. You can go from 0 to 3. That will start at the 0th character and go up to but not include the 3rd character, so it's 3 characters, 0, 1, and 2. You can go from 3 to 6, that's the next 3 characters, and here you can go from 3 from the end to the end, so it's LD exclamation point. These are ways to pick pieces of a string off, and these are going to be very important as you go into projects. Oh, I see my face is blocking some of this. Let me bring this down a bit. All right. All right. Yeah, that should do. All right. And now the last one is finding the comma in the string hello world. And you see the way it works is you give it the name of the string and then find to find something, and the answer will be the location of that. So 0, 1, 2, 3, 4, 5. A will be 5, and so you can print :A. That'll give you the portion before the comma, which is hello. So those are examples of some simple ways to find and cut out pieces of a string. And now you can do some networking. So that's what this one does. Let me make another block of code here. All right, so this one will import the socket library, which is classic raw sockets straight from Berkeley Standard Unix that defined TCP/IP and what eventually became the internet. And so I create a socket object, and then I connect to a server on a port number. So it's one of my servers on a high port number. And if the server replies, so the connect does the TCP handshake, which if you've done your networking is SYN, SYNAC, ACK. And then it's going to print whatever comes back with this receive command. And then it's going to send hello from Python and print whatever comes back. So if I run it, this server says, hello, what have you to say? And I said hello from Python, and it echoes whatever you say back. It says you said and echoes it back. So this is a simple echo server. In fact, it's a similar Python script running on my server. So now there are flags you can get here. You can take this one and modify it so it sends goodbye to a different port. And then this is the one that'll take a little bit of work. You have to increment it. So let me make some progress on demonstrating how this one will work. So first I connect on port 10203. Okay. And so first I would leave it, I change nothing else. I want to see what this program does. I'm going to connect to this other port, and I'm just going to send it hello from Python and see what happens. And when you connect, here's what it does. It says, hello, your number is 88. And what you have to do is add 1 to that number and send it back. So you're going to have to pick out this part of the response, turn it into an integer, add 1 to it, and turn it into a string and send it back. So a way to get there is instead of printing out what's received, you put it in a variable so you can work with it. So instead of printing sReceive, you do r equals sReceive. Get rid of the extra. Now I have a variable. Now I can print r, say 10 to 20. Remember, we talked about how to break up a string before. This is going to print part of the string, and I'm also going to print the complete R so I can compare it. So I'm going to print the complete response here, and then a portion of the response. So when I run that, okay, hello, your number is 70, and from 10 to 20 is number. So what you'd have to do is change these numbers until you get the number at the end. So it's going to be higher. It's going to be like 35 to 37, something like that. And then you can turn that into an integer, add 1 to it, turn it back into a string, and send it back to the server to get the flag. But that's the kind of work you have to do. Use both some networking and some string manipulations to solve this one. All right, and then there's loops, because we're ultimately going to get to where you break into websites by trying multiple passwords. So here's how loops look in Python. The for loops are extremely useful. I have some students that have not used them before. I know them from a very ancient language called BASIC. They were the simplest kind of loop to use. For I in range of 3, we'll just count from 0 to 3. And you can also say for C in cat, it'll just go through the letters in the string, C-A-T. So you can make a loop to do anything you want. And so now, by using a loop, you can do this one. This one here, if you go on port 10204, then you'll see that it says add these numbers, and you have to send the add, and sometimes it says subtract these numbers. So you're going to have to put this in a variable, and then take at least the first letter to decide if it's add or subtract, and then cut out these numbers, perform the operation, and send them back. And you have to do it 5 times to get the flag, quickly, within like 3 seconds. So you can't do it by hand. So that's, by the way, only connect once. You have a connect line here. If you connect 5 times, you'll never get the flag because you keep resetting the whole puzzle, and it's trying to get 5 answers. You have to connect once and then make a loop that does it 5 times, and then you'll get the flag at the end. So there's a few to find there. And the last thing is to talk about ASCII encoding and Unicode for strings. So if I go down here and make another block of code, all right, here I can define a set of letters, and we'll see something strange happen here. So this is how you define a character by hex code. So like hex code of 41 and hex code of 42, that's a capital A and a capital B. And then I'm going to put in FF, which is not a valid ASCII number. Let me bring up an ASCII table here just to show you that. All right, here's an ASCII table. All right, and I'll zoom in a bit. Okay, so this is the ASCII table, and if you look at it, you'll see capital A is 41 in hex and 42, and it only goes up to 127, which is 7F. The second half of all the 256 possible numbers is never used. So sending it FF, which is 255 in hex, is an invalid ASCII character. So I define a 3 character string here, and then I print them out, and what I'll see is, oh, I wanted to print all of these, so in this environment I have to put explicit print statements on each one. So let me copy that and put it on each one, because it's only going to print the last one otherwise. And now I got to put in the closing quotes. There. So the whole thing is ABY, ABY. This strange character here turned into a strange Y with an umlaut, a strange character. And that is interesting because it's not a valid ASCII character. It's not clear what it should do. And what happens is you can see the bytes used to store the string by doing an encode and then looking at the bytes. And so here, let's take a look at the bytes. And again, in this environment, I'm going to have to add that explicit print command to see them all. So I'll copy that and put it here and here and close all those parentheses. All right. And so now you see 41, 42, and the third 01, and the next two are C3BF. So this is pretty mysterious. Now I set it to this hexadecimal value, 255, as a character, but it turned it into a 2-byte character, C3BF. And what's going on is Python uses UTF-8, a form of Unicode. And so that looks like this. The first 127 characters are used as a single byte, just like ASCII, but then it has 2 bytes for some, and 3 bytes for more, and 4 bytes for more. So it encodes a lot of characters, like a total of 2 million possible characters this way. This is what's used in the modern world, UTF-8. So it covers all the commercial languages like Chinese and Hebrew and Arabic and everything, and all the emoticons. So you can see here, if you try these, 41 will be a Unicode error, \U, 41 is not allowed. You can only do it if you give it all 4 bytes, 000041 for the \U Unicode. And when you do that, it's an A. And all right, so if you use the FF back U, FF, and you put in the 0000FF, then it is the Y with an umlaut in it. But that's really BFC3. So it's a strange thing. It converts it into a valid Unicode character. And so you can find some Unicode characters. Here's a Greek symbol sigma. Here's a hamburger emoticon. You can find the Unicode characters for them. Anyway, this is a thing to get used to. This is a modern string. Python 3 uses modern strings. A proper string is a list of characters, and each character is a Unicode character which has a variable length from 1 to 4 bytes. In Python 2 and C, a string is just a byte array and each character is 1 byte, and that only works if the only language that matters is English. But in the modern world, lots of languages matter, so you need a much more flexible description of what a string is. So that's what I wanted to show you there.